Okay, we're going to be taking a look at some derivative rules here, and you're going to find that the limit of the difference quotient is a thing of the past. So let's take a look at some rules here, and then we'll try to go over some examples that we can squeeze in. It says if f of x equals c, the first one says is the derivative of a constant. If f of x equals c, then f prime of x equals 0. So this is the derivative of a constant, and to give you an example, suppose I said f of x equals 5. So then if I say, well, what's the derivative of 5? Well, it's 0. So the derivative of any constant is 0. Now on the next one, this one is called the power rule, and this one is probably the most famous, I guess, because it's probably the easiest. The power rule says if f of x equals x to the nth, then f prime of x equals n times x to the n minus 1. So let's suppose I have an example like, I don't know, x to the 4th power. Okay, well, I can say then f prime of x is going to be 4 times x, and then we're going to subtract 1 from 4, so to the 3rd power, so 4x cubed, just like that. Okay, so the power rule, definitely one of the easier rules here, just like the derivative of the constant. What about the constant multiple variation of the power rule? Well, that's not too difficult either. If you've got the hang of the power rule, then this one is an easy one too. Okay, so if I say f of x equals, I don't know, let's say 5x to the 9th power. All right, so then what we're going to do to find f prime of x is we're going to say bring down the 9 times 5 times x, and then we're going to reduce the power from 9 by 1, so to the 8th power. So that's going to be 9 times 5, 45x to the 8th power. So that's an example there. All right, now if we look at the last rule, the derivative sum rule, all right, this one right here is actually not too bad either. Let's see if I can squeeze something in here. Suppose I have f of x equals, I don't know, x to the negative 2 plus, let's just stick with something like 4x cubed. All right, so then my f prime of x, and I'm glad I picked a negative exponent rule there. I'm going to bring down the negative 2, so the negative 2 comes in front, x, all right, and negative 2 minus 1 is negative 3, all right, plus, okay, 3 times 4 is 12, x to the 2nd power, because you subtract 1. So that's what something like that would look like. And of course you could adjust this and work with the negative exponents, but I'll leave that to you. Okay, so these are just some of the very basic derivative rules, and you're going to combine them later on with other rules, and it's actually really neat. But let's go ahead and take a look at a couple of examples. So if I look at this first problem, it says y equals 4x to the 4th plus 5x cubed plus 4. So we're kind of hitting a multitude of these rules here. The power rule, I see it in play, but the constant multiple power rule version, the derivative of the constant, the derivative sum rule. The same thing works anyway with a derivative difference. Okay, so whether it's plus or minus, it doesn't make a difference. You just preserve the sign. But let's take a look at y prime here. If I say y equals 4x to the 4th plus 5x cubed plus 4, then y prime, its derivative, is going to be 4 times 4, 16, and then x to the 4 minus 1, which is 3, plus, okay, 3 times 5, which is 15, x to the 3 minus 1, which is 2, and then the derivative of 4 is just 0. So that goes to 0, so we don't have to worry about it. So right here, this right here serves as the derivative of 4x to the 4th plus 5x cubed plus 4. It is 16x cubed plus 15x squared. And of course, if they asked you later on to find the slope of the tangent at some point, all you'd have to do is plug in that x value, and whatever results is the slope of the tangent there. So let's go ahead and take a look at another example. So here on this second problem, we have some stuff that looks a little bit interesting. What I'm going to tell you is the first thing that we need to do is rewrite this function w, and we want to rewrite it in so that it only has exponents. So z to the minus 4 is okay, but 1 over z is z to the negative 1. Okay, so you're going to recall from algebra the negative exponent rule. All right, the negative exponent rule. And let's see what that looks like. If you had something like x to the minus n, well, that's the same as 1 over x to the nth, and it goes both ways. Okay, so it's interchangeable. So 1 over z was really z to the minus 1. Now that we've done that, we can apply the power rule, and we're going to have this negative 4 come down. We're going to have negative 4z, and then negative 4 minus 1 is negative 5. And then the negative and the negative makes for a positive, okay, z. And then we subtract 1 and we get negative 2. You have to be very careful when you're dealing with negative exponents that you always subtract 1 instead of add 1. So be very careful. All right, working with integers there. So this is the general answer right here. But let's go ahead and write it out with positive or expressed using positive exponents. So I might say negative 4 over z to the 5th power plus 1 over z to the 2nd power, 1 over z squared. So that is another way that that answer might look if you're asked to express your answer using only positive exponents. So that may be the case. All right, so definitely a good set of rules here to go by for derivatives. I hope this video was helpful, and as always, like and subscribe.